Okay, yeah, so we are going to get started. I'll be sharing my screen. Today is the last day for robotics and for the robotics class. And from here now, we will be working on onboarding, onboarding your learners, and we'll be working with you the journey. I guess you can see my screen. Eunice, can you hear me?
Yes, I can hear you. Yes, hello.
I think you're on mute. Okay, perfect. Sawa. That's in order. Okay. You can see my screen?
Yes.
Yes.
Okay. So kindly head to RoboSim and then click on training. Once you get to training, open just a second. Okay. So teaching and training. My computer is local because I have several applications running at the same time. We are also live on YouTube. For those who will be need of the recording, you can access it from our YouTube channel. Then head to advanced training. Super track 1. Super track 1 kindly. Super track 1. Download the map. Ready. Okay. So we have our super truck one here. Okay. I hope you can all see. You can all see this. So let's load our robot first. Let's see if the robot will load. So we may need to do some modification on the robot first. Let me see which tasks to close because my computer is running. It's heavy. Okay. We have a design that we've been using. So today we'll modify it a little bit. Robot design, let's see, 7th build. Let's see this. I think we had modified this. Yeah, this is the last design we modified. So we can modify it further. So I can remove this piece. I'll share it on the group for those who may not have time to redesign their own. Copy, paste. I'm just adding one more sensor, nothing much. Just adding one more sensor. Then okay. So looking for ideas on how we can make this table. Let me see. So if I take this and I make it upside down, this is not the only way. There are so many ways of doing this. This is just one of them that I can figure out at the moment. Feel free to explore your creativity and come up with your own methods. So once I flip it, okay. So this may not work. Let me see which other options I have. I need a right angle. So right angle, I have this. Okay, so let me try this one. Yeah, today is our last robotics class, so the rest will be focusing on helping you deliver the rest of the classes. So today is the last class for teaching this term, robotics. Okay, so once I have it that way, I can flip it again. Yeah, so today I'm a bit unwell, but we have to keep it going. Okay. So that's that is in order. So I need one more. Sorry. So they need to be 3. Oh, sorry. Control Z. Yeah. Yeah. So copy V, and I take it the other side. And I do the same here. Then I do the same here. Yeah. Yeah, so once that is done, then now we can proceed to, let me see if this can help. If we put it somewhere here, yes, it can. So let's get the connectors. There. Get another one. There. And I get another one. There. Okay. There. Okay. And I do the same. These are the side. Okay, so I do the same to the other side. I get it here. I get this. I get this here. I get it here. I get this one here. So I do that. So I check if they are of the same length, of which I can see one. Is it overlapping? Okay, so this should be somewhere there. Okay, it should now be okay. Then I alight all this and I pull them. I fix them somewhere there. Let me see. This is 12th grade. Do you have any other grade? Any? Let me see. We have 9, 10, actually 10, 12, 12, the biggest. Okay, so we can save it as, let's cancel that. Save as. Teachers cohort 1. Cohort 1. So very long name. So we save it. And now we come to the simulation. So you can see our robot has loaded. Our robot is here, okay? Our robot is here. Yeah, so let's confirm. Let's check on our sensors. So the first one is connected to P1. This is connected to P3. So we'll change it to P2. And then the last one will have it at P3. So that's okay. We've reconfigured our robot. So I'll stop sharing for some time. to check if we proceed. Any teacher with any question? Any questions so far? Hello? Hello? Gad, do you have any question? Yes,
No
Eunice.
question. No question.
Okay. Okay, thank you. So, there being any other question, uh, we can proceed to programming. I wanted to send you this design first on WhatsApp. So for those who are struggling with the design, you can just download it. Okay, I'll send it to you in a few. Let me see. Okay, so we proceed. I'll be sending. Yeah. So with that, then we can start programming it. Line with the two sensors this time around. We can do it with three sensors and have one sensor to just check if our robot is on a junction or it's supposed to follow a straight line. So to get started, we can we can do the functions, motor 1, motor 2, so let's see, motor 1, motor 2. Okay. Let's see if it will move our motor forward. That's in order. Our robot is going forward. As you can see, P2 is on the black line, okay? Until that point, the change, okay? So P2 is on the black line, and I'll just come back here and say this is now moving forward. Blocks, that is functions, and make a block and call it so that is forward. That is forward. Then once that is done, then I'll have this as the definition of the forward motion. So forward motion, that's the definition of the forward motion, okay? Then I'll take this forward and put it here. Oh, sorry. We'll use it later. So let's do for reverse. Reverse definitely will be the opposite of forward. So in terms of the direction of the wheels or directions and how this has reversed. We have discussed this in length in our previous lesson. But in case you have any question, feel free to ask. That is reverse. So reverse, and then I'll okay that, and once I've okayed that, yeah, that is reverse. That is reverse, and then I'm just refreshing my screen. Okay. Don't worry. Okay, I'm refreshing my screen. Okay, so that's reverse, and I'll have this as the definition for reverse. Okay, so if I say reverse, then I expect the robot to move backwards. So let's see if the robot will move backwards. As you can see, the robot is moving backwards. Perfect. So let's do for left and right. Left and right. So left and right, then as we had discussed in our previous class, one of the motor to turn left, then the motor on the left. Okay, there are so many techniques for turning, but this time round we're just reversing one motor differential. So turning left, then the motor on the left should be reversed. So M1 is on the left, should be reversed, and then this one should be positive. Okay, so let's see if that will work. If we do this, perfect. So that's it turned left. Sorry. And then of course we can always use a reduced speed. Okay, for the turn. You can reduce the speed of the turn. Okay, and then we make a block and call this left. Okay, so that is left, and we have this as the definition of left. Then if that's left, then the opposite should give us right. Okay, opposite should give us right. So we are still making our functions, so we can start writing our logic. Right. Okay. So we can say turn right. Turn right. Okay. The other should be turn left, turn right. So the opposite should give us, and the opposite of this should be 30 and negative 30. So this should be 30. The other should be negated. And there we go. We have it there. Okay. Okay, so next step is to, the next step is now to write the logic. And to write the logic, we have to get our robot on the platform, okay? As you can see, there is no code here. But if I wanted this robot to start moving, then I'll tell it, like right now it's saying 111, okay? 111. So when there is 111, okay, 111 at this point. So we can maybe tell our robot to get started. The first thing, motor 1, motor 2, forward. So the first thing, forward. Okay, forward until it goes astray. So let's see. The goal is to follow the line. So if we tell our robot to go forward here at this point, it's going forward. Okay, at this point it has left the line. So if you are to debug, I'll take this robot back here to get to determine at what point does it go astray. So I can always restart it. Okay, I can always use the debug mode. Debug mode, because these I can always stop at any given time. I stop it there. I zoom that situation, that scenario, because I want to examine at what point do my robot go offline. Again, so when P2, P3 are seeing the black line and P1 is not seeing, okay? P2, P3 are seeing on the black line. I'm using the data panel. Check the data panel here. P2, P3, 1, P2, P3. The sensor at the sensor at the center and on the extreme end to the right are seeing the black line, but then the sensor to the left is not seeing the black line. So we need to have that condition. So if that condition happens, so we need to get an if then. Yeah, if then at this point, if then, so if then, and we need to include that condition. If P, sorry, the sensors, get light sensor, the digital values. I have 3 sensors. So I'll have 3 of this, and I have P1, P2, P3, P1, P2, and P3. And I have now the control, yes, operators, this and this and this. So, and I'll duplicate this and have it here. So which sensors? P2, P3, P2, P3. Like in P1 note. So P1 note, P1 note, P1 note, and then these two are seeing the line. These two are seeing the values, P2 and P3. Then now we drag this and put it there, okay? Then at this point, where do we turn? Any teacher? Where do we turn for us to follow the line? Which direction?
Right.
Oh, perfect. So we turn right. So we just come here and say turn right at that particular point. So let's redo our code. Let's reset our robot and restart it. Oh, sorry. Okay. Let's see. P1, P2, P3. It happened so fast. Let's see if it will turn right. If we reduce the speed of forward. Let's say 30. On reverse. Okay. It turned, it turned, and then there's a condition that was true. When now it turned when P2 was on the line and P1 P3 was not seeing the line, so we need to include that as well and tell it now at that point you need to continue moving forward. So note, so this should also be note, and then P2 is on the line, so note, and let's see. Sorry. Okay. So you can see it's turning like immediately, okay? It's losing bearing. So at this point, we can tell it turn forward. We add some delay here to keep it going forward for some time. Yeah. So let's keep it 2 seconds before it runs the other code. Now we fix that. So as you can see, we are fixing our bugs one by one. Okay, this time round it didn't turn. Let's try it again. Okay. Okay, what could be the problem? Because this is on a loop, so we could forward. Okay, so this is on a loop. So this forward could be before the forever block. So it doesn't have to repeat the same process. Let's see now. Something interesting. Okay, so it tried to correct it, turning right. So at what time is it supposed to go left? When let's see. When it's this way, let's simulate that. For example, if it was correcting and then it gets to a point when P1 is the one seeing the line. P1 is the one seeing the line. P2, P3 are not seeing the line. As well, and that should be turn left. So P1 seeing the line and the rest are not. P1 seeing the line, the rest are not. Then it should be turn left. Okay, let's see now. Very good. So we are almost there. So when are we supposed to move forward? When are we supposed to move forward? At this point, it's just doing turning left, turning right, just correcting the line, but it doesn't know when it's supposed to move forward. So forward, when are we supposed to move forward? So we need a forward here. As you can see, I'm doing this step by step so we can better understand. Okay, you can see our robot is stuck here. We need to tell it, we need to program it to know that it's now time to move forward. Okay. So when is it supposed to move forward? We'll have to stop that and come back to the code, and I'll tell it to go forward at this time. So, uh, huh. So forward, it should be going forward when only P2 is on the black line. P2 is the sensor on the sensor at the center. Okay. When only P2, when only P2 is seeing the line, P1 and P1 and P3 are not seeing the black line. Okay. We have some exceptional cases, but then we'll handle those ones later. But this is basic line following. Yeah. Basic line following line. The rest are not. When P2 is seeing the line, the rest are not. So P2, then this is not seeing the line. Then this should be forward. This should be forward. Okay, let me check. Let me just confirm. Sorry. Let me confirm how this code, if this code is making sense. Just a second. Um, just a second. If not, RCU gets that sensor. RCU. If not, RCU gets if not, RCU. Yeah, that should be okay. That should be okay. So we run our code. So you can see it's not dancing and it's able to correct itself. Okay, let's just stop that. Sorry. There was some bug there. There was some bug there. Program assumption. Okay. So we need to modify the code. There is some bug somewhere. Not, not and not. That's okay. Let's see. Okay. Let's simulate it. So as you can see, the robot is able to follow the line, but then we are having issues with turn. So we may need to fix that. Note and very good. Note and note. Wait a minute. This code at this point, it's the same as this point. So I guess this should not be here. It's conflicting. It's conflicting. Okay, this is conflicting. Sorry. We have two turn rights that are conflicting. Notes and. So when we have it here, this is not seeing the line, and these two are seeing the line. At this point, this is not seeing the line. This is seeing the line. That is P1, and these two are not seeing the line. Then we turn left. That is right. This is not seeing the line, and this is not seeing the line. This is not seeing the line. Okay, so let's simulate again. Perfect. So at that point, our robot was able to follow the line until this point. Let's just check it again and see if there is any issue with the turn. Maybe our turning technique is not working properly. So we may have to save the code. We do with this part. So turning, let's do 20 and 20. Let's reduce the turning speed further. 20, turn again, or is turn left? 20, 20, forward, yeah, that's okay, left and right, that is okay. Let's simulate that. Okay, at that point, so we can turn until. So at this point, turn until. So turn until this. If this, turn until. So we could use wait until. Turn right. So we could use wait until we see a particular condition. So turn right, then wait until this condition for forward is true. Turn until this condition is true. So sorry, I didn't duplicate it properly. So we could say wait until this condition is true. Yeah, so turn right until this condition is true, then move to the next code. So let's see. Let's see this. This is interesting. Let's use the debug mode so we can pause it. P2 is on the black line. P2. Now we have P2, P3. Okay. P2, P3. Okay. So P2, P3, and then it goes away. Okay. So let's take it back a little bit. P2, P3. Sorry. Okay. We are almost there. Let's try zoom it further. Okay. When P1 is seeing the line and P2, P3 is not seeing the line, what should we do? P1 is seeing the line and this is not. So turn left until turn left, wait until this condition, because this is the condition for forward. So let's see again. Sorry. Okay. Okay. That's okay. Let's see if we start this robot from here. And then it change. It could be. Sorry. Oh, unfortunately, it looks like our line flowing code is not working properly. We may have to redo it. We may have to redo this. Okay. Let's check on. Okay, so let's do this one by one. Just a second. Let's debug this. Okay, let's have forward and forward. Okay. Forever. Okay, let's have the two if blocks and see if there is any challenge with the two first. Sorry, this should start from the beginning. Okay. So turning left. Sorry, this is right. This is turning right. So turning right, turn right. Wait until this. Okay. Let's try eliminate that part and see. Okay. Let's try to reduce the turning speed even further. Turn right 10, this to -10. -10, this to 10. So Okay, so we may introduce a variable at this point to record that turn. So say junction. So we may call it junction. For example, can give it any other name, but let's do a variable and call it or J tracker. Right corner tracker to help us track the corners. For example, you can give it any other name. So when we get there, if this is true, Then set, so when we are starting, let's set it to 0. And then change, once we get there, change R1 by 1, okay? Then once that is true, then now wait until, okay, so if this is true, if error, so we may add another code here. There are so many ways of doing this. This is just one of them. So we may add another code at this point and say, if RC1, so if RC tracker is greater than 1, because it will be registered here, greater than 1, so that is operators, and say greater than 1, and that will be RC tracker. Hello? Yeah, I'm in class. We answer to your meeting. If RC tracker is greater than 1, then wait until let me see if that's making sense. This part of code did not bring any change. So again, there are so many ways of doing this. So the other way we could achieve that is now change the turning technique. Okay, so if because differential works with smooth edges. So for example, if the robot was to navigate these corners, then differential will work best. But then for the sharp edges, let's try reducing one speed. So if we are to reduce one speed, like speed of one wheel, then for right, okay, then now for that we can retain our code, our original code. Let me see if I can bring it back. For right, it will be for right, it will be, let's see, right. The speed of the right side, could be lower. So this could be 10, and this could be 20. Okay, and then the left, this could be left. This could be 10, and then this could be 20. Okay. Let's see that. Turn right, turn forward. Then we need now turn left. Oh, okay. Already have 10 left here. So 10 left. Turn right, turn left. Not. Uh-huh. Okay. Let's see. Yeah, we achieved the turn, but then we turned very, very far. I believe that can be smoothened. That can be smoothened. Let's see. Uh, so turn left. The other alternative is to stop one motor. To stop one motor. So and make the other move. So let's try that. We're just trying different turning techniques. That's what we are learning at the same time. Stopping one more time to adjust the other. So let's see. Uh-huh. Yeah, that worked. That solved our problem. Then if none of the if none of the if none of the sensors is seeing a black line, then we could tell our robot to stop. If none of the sensors is seeing the line, then we could tell our robot to stop. So let's see. If not, or reverse I think would be better. So it can pick it from the last point. I hope that won't be messy. Also with the turns, notes. Then these also are not. Okay, kindly note that the codes that are hanging are commented. So they're not part of this. So any code that is not under when RCU starts is not part of the main one. Okay. So if not, then of course there are better ways of doing this than what we're currently doing. Then this should be reversed. This should be reversed. Let's see how that will behave. Okay. The best way of learning is by doing. So I hope you'll find time to do this with me. Let's see if it will reverse. Okay, so so you can see what's happening. Our robot is not able to move. Sorry. So at this point, then if not, we could also implement stop. Though stop will end everything, so I don't think this is a good idea. Our robot got lost at this point. At this point, we almost got it this time around. P1 is seeing the line, P2, P3 are not seeing the line. P1 line, P2, P3 left. Let's try remove that. Okay, just a second. Let me try to close my my RoboSim. Super million day 3 just training. Okay. Five. Someone. Let's see. Let's save it there. And then I try close my RoboSim. For the times when you're having issues with the software, when you have a lot running on the background, the software doesn't work properly.